The objectives of this video are, in Network 1, demonstrate IPv6 SLAAC configuration of host machines. In Network 2, demonstrate IPv6 SLAAC with DHCPv6, that is stateless DHCPv6 configuration of host machines. We also want to view router solicitation messages, router advertisement messages, and neighbor discovery messages by turning on debug IPv6 neighbor discovery. Now here's our network. Router R01 is connected to a local area network, has switch 0. Now PC0 and PC1 are initially disconnected from the switch to facilitate the debug capture we want to see. Here's our router configuration. We only need to configure an IPv6 address on gigabit 00, of course do a no shut, and at the global configuration prompt, turn on IPv6 unicast routing. Now we'll connect PC0 and PC1 to the switch. Fast forward time. Our debug IPv6 neighbor discovery is turned on. Now we'll toggle to go to static, back to auto config, and we can see both PCs are now configured using the SLAAC algorithm, stateless address auto configuration. Let's look at our debug output. Here in the debug output, we see the router solicitation from host ending in 6583, that's PC0, followed by the router advertisement. That router advertisement goes to the destination multicast address, FF02, which is the all nodes address. So both PC0 and PC1 hear this router advertisement, and they both successfully configure. Also, we see the neighbor discovery duplicate address detect messages from PC0 and PC1. Notice the source link local addresses 65A3 and CD6A. Neither gets a reply from another machine, therefore they keep the IPv6 address that they've configured. Now we'll configure interface G01 on router R01. So we have connectivity to the server out here at 2002::2. First, let's turn off our debugging. And now we want to verify connectivity through this network from these PCs through the router to the server. We'll use ping. So we've demonstrated full connectivity after our SLAAC configuration of these two PCs through the router out to server at 2002::2. Now here in Network 2, we're configuring router R23 with SLAAC with stateless DHCPv6 configuration. Now we're going to use the other flag, instructing the router to send other configuration information to the host machines that are sending out router solicitations. We're going to get the other information from this pool named ABCDEFG. We define pool ABCDEFG up here, and the only information we have here in the IPv6 DHCP pool is the DNS server address. So now let's configure router R23. Notice when we configure the router, we're going to turn on debugging IPv6 DHCP detail. Now let's see what debugging information is generated. We're going to go from static to autoconfig. First, let's hit fast forward time. So we've triggered a router solicitation from this PC. Notice that the other PC was not configured. So we'll trigger a router solicitation there as well. All right, let's look at what we've captured in the debugger. We can see that not only did both machines auto-configure their IP addresses, their IPv6 addresses, using the prefix from the router, but we also see the DNS server, which came as a result of the other flag being set. Now let's finish configuring router R23. We only need to put an address on gigabit 01. And now our objective is to see the PC access the server with the URL, which means it's going to be using the DNS server. PC2. And we see we successfully get to the website using the URL, therefore we did use the DNS server. That concludes this video.